In this presentation, we're going to look at the ratio test. So this is a worked exercise in the context of, essentially what we're doing is we're working with the ratio test. What we have down here is a series, and that's the terms there. So the series, the general term here is this one, is this expression here. This is the general term. This is the series here. And the general term is n plus 1 over 2 to the power of n. Okay. So this is quite important to be able to pick out this general term here, u of n. Okay. So what we're going to do is test this for convergence. So let's move along on that, this series, and let's go down here. My machine is jamming up. There we go. Now, so u of n is n plus 1 over 2 to the n. Now this is important, this bit, is that we could also, so that's the general term there, 1 over u of n is just actually flip it round. Flip it from top to bottom like that. So put the numerator below and the denominator on top. Simple as that. Okay, we're going to use that later on. And then what we're going to do here is u of n plus 1. So we're just going to derive this expression here. If we have n plus 1, put in, every time in u of n, where we have n, put in n plus 1. So we have 2 to the power of n plus 1, like that. And if you simplify it out, you will get n plus 2 over 2 times n plus 2. Okay. Now, what I'm going to do is actually just quickly remark that 2 times n plus 2 is simply 2 times 2 to the power of n plus 1. So, it's always very important to know those little power rules. Okay. If you don't believe me, you can work backwards, add the two powers, 1 and n plus 1, and you get n plus 2. Now, this is what we're particularly interested in. The absolute value of u of n plus 1 over un. Okay. Now the absolute value is denoted by those two bars on either side of that fraction. But we're not particularly interested in them, so we're not going to really work. Well, I'll put them in here as well. But essentially, u of n plus 1 divided by u of n is the same as u of n plus 1 times 1 over un. Okay. So what I'm going to do is write out that expression there. And let's have a look at it. It is equal to n plus 2 over 2 times 2 to the n plus 1. That's u of n. Times 2 to the n. What am I doing here? Sorry, I've just jumped too far ahead here. Let's actually go back here. 2n plus 1. I just went a bit too far here at this step here. Little typo there. So 2 in the n plus 1 is simply 2 times 2 to the power of n. Okay. So let's just fix that little typo there. 2 to the power of n over n plus 1. Okay. So I'm back on track now. I just made a typo there, a little mistake there where I just jumped too far ahead when I was doing this bit. Okay. But anyway, I'm back on track now. So the n, 2 to the n, that cancels out with that. Nothing else cancels out. So what we could just do is re-express the expression like that. 2 times n plus 1 multiplied out. Or in other words, n plus 2 over 2n plus 2. Okay. So that is the absolute value of that fraction. Now the ratio test is, we have to calculate this limit L, and it's the limit of, as n goes to infinity, of u of n plus 1 over un. And that was equal to n plus 2 over 2n plus 2. Okay. The absolute value of that. Okay. Now, in this situation, what we're going to do is, when we have fractions like that, and their limit is n to infinity, what we could do here is actually divide by the highest power of n. In this case, the highest power of n is 1. So we divide through by the highest power of n. Anyway, this 2 over n, as n goes to infinity, that becomes 0, just using your basic limits rules. Likewise, 2 over n, that becomes 0 also. So the limit is the absolute value of 1/2, which is a half. Okay, so here this is actually from a previous one. Here the limit L is 1/2, and the rule is, this is the rule we're sort of looking at. If L is less than 1, series is convergent, and it is less than 1, so the series is convergent. Okay, so that's our answer. Okay, now it would be worth keeping in mind what happens in other situations. If L was greater than 1, we would sort of say it's divergent, and if L is equal to 1, well, it doesn't really mean anything. It could be any. Essentially, we'll just sort of say it's inconclusive. But anyway, going back to our overall answer, L is equal to 1/2, so the series is convergent.